Fusion bonded epoxy, often known as powder coating or FBE, is a common corrosion protection technique used in the oil and gas industry for buried and submerged pipelines. This environmentally friendly epoxy-based powder coating contains thermoset polymer, transforms from powder to liquid at temperatures ranging from 180 to 250 degrees Celsius, and cures immediately through chemical cross-linking, assisted by heat, which is known as fusion bonding. If you want to learn more about the FBE coating application process, inspections, and testing, the Institute for Oil and Gas Sector developed these FBE series videos to help its students gain a comprehensive understanding of the FBE coating. In the first video of the series, the application process of the three-layer pipeline coating system is introduced, with FBE coating serving as the first layer in the system. Be sure to watch the entire video for all the important information about the FBE application, and don't miss out on subscribing to the Institute's YouTube channel to stay up to date with the latest videos in the series and other educational materials about the oil and gas industry. The FBE application on pipeline pipes begins with the delivery of the pipes from the pipe mills to the FBE plant. The first step involves carrying out an incoming inspection of the pipe to verify that the received materials meet the specified requirements. The next step is to assess the physical condition of the pipes and determine the presence of rust grade. This process makes sure to decide on the appropriate surface preparation method before coating. Nevertheless, it is generally accepted that surface preparation to white metal or near white metal is suitable in the majority of circumstances. The FBE application is an automated process that begins with the use of a mobile crane to transfer the pipes to the incoming rack of the coating application area. The coating application area is divided into multiple sections, and the pipes sequentially move from one to the next in a spiral pattern with the help of Rubbermaid rollers while maintaining the required speed. The first step during the application process is to wash the pipes with potable water. This is done by passing the pipes through an enclosed section of water washing. This process effectively removes the unwanted contaminants from the surface of the pipe, including soluble salts. After the water washing, the pipes are heated by passing through the heating section to remove the moisture that typically forms on the body of the pipe after the water wash. This process ensures the steel temperature fulfills the coating manufacturer's recommendations before further cleaning. The pipes next proceed to the abrasive blast cleaning section, where the pipe surfaces are cleaned by centrifugal blasting methods with abrasives of the specified type and size. The abrasive blast cleaning removes all dust, dirt, mill scale, rust, and corrosion residues, and other contaminants from the pipe surface, bringing it close to white or near white metal cleanliness level, while generating a rough surface for coating adhesion. Following the cleaning process, the pipes then move to the surface preparation inspection and testing rack, where coating inspectors inspect and test the prepared surface to ensure that it fulfills the necessary cleanliness and roughness standards. They carry out a variety of tests at this stage, including visual inspection, profile measuring, and salt and dust testing. At this stage, it is also important to identify and address surface defects on pipes, including pitting, raised silver, laminations, or steel hackles. These defects are often visible after blast cleaning. Once identified, they must be remedied according to the set criteria. After passing the surface preparation inspections and tests, a self-adhesive tape is wrapped around the pipe, approximately 150 millimeters from each end, to provide a cutback for on-site welding before installation. Pipes then move to the preheating section, where enclosed ovens heat the entire body of the pipe for the second time to the required temperature for FBE application. The oven operator sets the oven temperature within the recommended range in the cabin while also measuring the temperature of the pipe using a contact thermometer. After the heating process, the pipes are moved to the coating application area. Here, the coating is applied to the pipe using the electrostatic spray method to the specified thickness. The first coating layer that the pipe receives is the FBE, which is typically green in color. After applying the FBE as the first layer, a second layer of abrasion-resistant coating is applied to protect it from damage during handling, storage, or installation. Subsequently, a rough coat is applied as the third layer over the abrasion-resistant coating to ensure adhesion with the concrete weight coating, often used to withstand seawater pressure. Following the application of all three coating layers, the pipes then move to the quenching section. The process of quenching involves the passage of water into coated pipes to reduce their temperature to 80 degrees Celsius or below. This enables the inspection and testing of the pipes without posing any safety risks, such as the risk of burning. After quenching, the coated pipes are directed to the final inspection and testing rack for destructive and non-destructive tests. The non-destructive test involves visually inspecting each coated pipe to see whether the coating is applied uniformly and visually appealing, with no visible defects. In addition to visual inspection, two common inspections and tests that are carried out on coated pipes are holiday detection and DFT measurement. The holiday tests find invisible defects in the coating, such as coating discontinuities or pinholes, and the dried film thickness test measures the coating thickness to confirm that it meets the recommendations. To carry out the holiday test, a high-voltage holiday detector is used, and a pick gauge is commonly used to measure the dry film thickness of individual layers, while an electronic thickness gauge measures the total thickness of the 3-layer coating system. Once all of the necessary inspection and testing on the coated pipes has been completed and confirmed acceptable, the pipes are marked for identification and their cutbacks are dressed before leaving the coating application premises. On the other hand, any coated pipe that has been found unacceptable is repaired or stripped and recoated. Following that, using a mobile crane, the coated pipes are stacked in the designated area or sent to the location where the concrete weight coating will be applied. Aside from the inspections and tests conducted at the final inspection rack, various destructive tests on the test pieces are carried out in the laboratory. To conduct the test, a pipe that has been coated during production is randomly selected. From this pipe, a test ring of the required size is cut from one end. This ring is then sliced into smaller pieces as required for the test. Cathodic disbondment, hot water soak, flexibility, cross-section and interface porosity, and dry adhesion are some of the most common destructive tests performed on the test pieces. In the next videos, we will demonstrate how these destructive tests are performed. So, to make sure you don't miss a single video broadcast by the Institute for Oil and Gas Sector, we recommend subscribing to the Institute's YouTube channel and pressing the bell icon for notification. You can also share this FBE application video with friends and colleagues to spread awareness of the FBE application process. Furthermore, if you have a desire to gain the necessary skills in paint coating or require a qualification in this reputed work field, the Institute for Oil and Gas Sector provides a wide range of training and certification courses. Enrolling in these courses will set you on the right track toward a career in the oil and gas industry's protective coating work field. More information about protective coating courses can be found on the Institute's official website, iogs.org. If you found this video helpful, please consider giving it a like and don't forget to subscribe to our YouTube channel and press the bell icon to receive notifications for upcoming videos in the series. Additionally, please refer to the description box below for more informative video links related to the oil and gas industry. Thank you.